Okay, everybody, if you're here, you want some algebra, and we'll try to give you more algebraic options if that's your thing as we go along as well. I like Excel, but not everybody does. We need equations. If we're going to do algebra, we need equations. And fortunately, we already came up with the equations when we did Excel. We came up with total cost equations. Total cost. And those total cost equations were fixed costs plus variable costs. So we have, I brought three colors, blue, green, and orange. We'll use orange for incandescent. For incandescent, the fixed cost was 50 cents, so that's 0.5, plus the variable cost of 0.006. As far as a variable goes, I'm going to use H for a variable for hours, just because that was what we were using that as the run variable. So an incandescent, that's the total cost of an incandescent after H hours. You plug an H value into that, and out pops the total cost. I'll use blue for CFL. CFL equals 3. It was $3 to buy one of those. Plus 0.0014 H. There we go. Oh, that's an H. There we go. And I'll use green for LED. LED. That one was most expensive at $5. Plus 0.001 H. Notice I used the same H for all three of the models, and that was intentional. We want to use the same H because that's the number of hours burned, and that's consistent amongst all three models. If you burn for 1 hour in incandescent, that's the same amount of time as a CFL, amount of time as an LED. Now, what we did on the last video was look at the break-even points where the lines crossed. Where the lines crossed, that means their X and Y values are the same. Algebraically, you might remember how to do this. You set the Y's equal to each other and then solve where the X's are. Or in this case, you set the total costs equal and you figure out where the hours are. So I'll do one, since we're on a fairly small board here, I'll just do one, and the same procedure would happen for any pairing. There's three ways we can pair these things off. We can compare incandescent to CFL. We did that one first in the video. We can also compare incandescent to LED. We did that one second in the video, and then you can do CFL to LED. We did that one third. I will do the second one, incandescent to LED. So for that break even, I'm going to do the incandescent LED break even. So what I want to do is, I'm going to do it down here in this little bit of space I got. I'm going to figure out, based on these models, at what number of hours does it become more efficient to purchase or to run an LED over an incandescent. Because we know at first the LED is more expensive than the incandescent, from 0 hours up to a certain number of hours. And then at that certain number of hours, it becomes cheaper to run the LED in total. So what I'm going to do is I'm going to set the incandescent total cost equal to the LED total cost. So we're going to set that equal to that, which means this is going to be equal to this. So you're going to have 0.5 plus 0.006H equal to 5 plus 0.001H. Get this out of the way. There. Okay. And then what we've got here is we've got a linear equation. These are all linear functions. This is now a linear equation. It's got one variable, H. And all we've got to do is solve that thing for H, and we're good to go. Okay, looking at this, and I notice something. I notice 0.5 is smaller than 5. So I'm going to move that over here. And because we did this correctly, we're also going to move this over to here, because this is smaller than this. This is 6 times bigger than that. So this is good. This is going to work out just fine. So we're going to move the 0.5 over to there, and that's going to give us $4.5, if you will. That's what that actually is. You took 50 cents away from $5. That's $4.50 now. Then I'm going to subtract this over to here. We're going to get 0.005H. Now, I want you to stop for a second and think about what you're looking at. This is actually pretty cool. There's some neat dimensional analysis going on. That's dollars, That's hours. This unit here has to be dollars per hour. You don't have to know this to solve the equation. Some of you are like at this point like, Sean, just divide by 0.005. Totally, very true. What this is telling us though is this is the overage LEDs have on an incandescent. That's the amount of money we have to make up the difference of, because this one starts at 5 and that one starts at 50 cents. So yeah, let's just go ahead and do it. H equals 4.5 divided by 0.005. I bet you we could do this in our heads. If this were 0.001, that would be 450, I believe. But it's 5 times, no, that's not quite right, 450. Yeah, I'm thinking this is going to be 900. I can't explain it very well. But if this were half, it would be 9. 0.05, it would be 90. 0.005, it's going to be 900. It's kind of one of those fun little things my brain does. If you don't like the way my brain does math, just go ahead and plug it in your calculator. 900 hours. So after 900 hours, the LED costs the same as the incandescent. Anything past that, the LED is going to be cheaper. You can do the exact same math that we just did by pairing off incandescent and CFL or CFL and LED. I'm out of board, so I think that'll do it for now. If you like algebra, there you go, and there's your solution method. We'll see you soon.